Hi, this is Mr. Salvador, and this is the fourth and final video in regards to Vsepr, or valence shell electron pair repulsion theory. This is a theory that we use to predict what a geometric shape a covalent compound will hold in real life in 3D in 3 dimension. And so you were responsible for 5 different geometric shapes. They were linear, bent, trigonoplanar, trigonopyramidal, and tetrahedral. We gave the requirements for it. So to be linear, you only have 2 bonds. To be bent, you have 2 bonds plus a lone pair of electrons on the center atom. For trigonoplanar, you have 3 bonds only. For trigonopyramidal, you have 3 bonds and a lone pair of electrons on the center. Those are the 2 dots right here, right? And then lastly, tetrahedral has 4 bonds, okay? So we talked about how you predict, how do you use this theory to predict the shape? Well, all you have to do is count the number of bonds or number of atoms connected to the center atom, and you got to see if it's got a lone pair of electrons on the center or not. So for instance, water right here has 2 bonds. You see 2 lines right here, right? And it's got 2 lone pairs of electrons. So yes, it's got 2 bonds, and it's also got lone pair. So which one has 2 bonds and a lone pair? Well, the only thing with 2 bonds is either linear or bent, but the one that has a lone pair is bent. So water is a bent molecule, has that shape. All right. Now, today last video, we're gonna see about polarity and symmetry. All compounds, all covalent compounds have a polarity, have a property known as polarity and symmetry. What is polarity? Well, polarity is this. When you have a bond between 2 elements, one element may be stronger than the other element, okay? That means even though the electrons are being shared, because that's what covalent is, covalent electrons are being shared, doesn't mean it's not being shared unequally, which means if I'm stronger, if one element is stronger than the other, then that electron is going to be a little bit closer to the stronger element. It's not directly in the center, right? It's a little bit closer to the stronger element, right? So like this tug of war picture you see here, if the bond is equally shared, that means that the electrons are right in the middle, they're equidistant from each other, and that means it's equally shared, and that means it's not polar. All right. However, most of the time, there's always a stronger element. That means the electrons are closer to that element than to the other. So when we have that situation, that is when we have a polar molecule, because the energies and the charges are going to be in slight imbalance, right? The electrons are going to be closer to one than the other. So when we have that situation, it is polar. Okay. The other thing is symmetry. If you look at a compound, a 3D molecule of a compound, um, depending on how you turn it, it's symmetrical. If everywhere you turn it, it still looks the same. All right. So from this direction, it looks the same. From that direction, it looks the same. From the top, it looks the same. It all looks the same, just like an identical twins. They look the same. So that's when you know this molecule or this compound is symmetrical. However, most of the time, elements and compounds are not symmetrical, which means the electrons are not equally shared, just like they're polar. So when you have a polar situation, this molecule does not look the same all over the place, right? It looks different from the top, from the bottom, all right? From the left, from the right, it looks different. So that is what we call a polar molecule, and polar molecules are asymmetrical. So to summarize, anytime you have a polar molecule, it's going to be asymmetrical. It's going to be asymmetrical. All right. It's not going to look the same. So if they're polar, they are asymmetrical. If they're nonpolar, they're symmetrical. So nonpolar means they look all alike any way you look at it. And if they don't look all alike in everywhere, then it's polar. All right. So let's look at our shapes. Linear has 2 bonds, as you can see right here, has 2 bonds, but it has no lone pair electrons on the atom, which means, and let's open it up so you can see it a little better, the chart a little bit better. So let's go. So if it's linear, and linear has 2 bonds, just like we did in the previous video, it also has no lone pair on the center, okay? No lone pair electrons on the center. So if it's got no lone pair and it's got 2 bonds, then it's not polar. When it's got a lone pair, that's when you get the polarity going, because that means unequally shared, okay? So nonpolar gets you symmetrical. Bent also has two bonds, but it also has a lone pair. So that tells me once we have a lone pair of electrons on the center, it's instantly polar. The electrons are not being shared equally, therefore it's going to be asymmetrical. So all the different shapes that have a lone pair of electrons, which is bent, which is trigonopyramidal, those two are polar molecules. Those are the ones that have a lone pair of electron on the center atom. Okay, so those two are polar. Now the other ones, linear, trigonoplanar, and tetrahedral, they don't have lone pairs, right? They don't. It's just bonds. All right. So when you have just bonds, it's not polar. All right, because everywhere you look at this thing, it looks the same. And so since it's not polar, it's very symmetrical. It all looks the same, top, bottom, left, right. They all look the same like identical twins. So that's how you work. So once you get a test question, they're going to ask you, what's the shape? And how do you tell the shape? Well, you just count bonds and count if there's a lone pair on the center atom. Once you determine the shape, because they tell you the criterion is right here, all right? And then from that, you instantly know if it's polar or nonpolar or symmetrical and asymmetrical, and that's it. That's all this is. So I hope you understand. If you're not, there's tutorials, and ask your teacher some questions, all right? Don't be afraid. We're here for you. We want to support you. We're here to get everybody to a passing grade, hopefully 85 or better, all right? Thank you very much. Have a great day.